1/2 cool motorized back flaps from Mark 46. I'll show you in this video next. So before we get started, I do want to give a quick shout out to Plentiful 3D. He has a fantastic tutorial on how to motorize back flaps on an Iron Man suit, and I definitely use some of the files that he has listed, especially his aileron system, A.I.M.E system files here, and he has a list of hardware that he used. Highly recommend viewing this. It's super helpful. I definitely use some of the things from his video in my suit. So just wanted to give a quick shout out to him. Thanks. All right, so we're gonna go over the parts you need for motorizing the back flaps. Of course, the main part you're gonna need are the servos. And I went with these 20 kilogram digital servos. You can find them on Amazon. I'll link in below. I found that these work better than the MG90s that most people use in Iron Man helmets for like faceplate motorization. These just did not have enough power, I felt like, or torque to hold the flaps open long enough. And getting adequate power and amps out of this, I could never get it to work. There's probably ways you could get it to work. I just found that these were a little bit more reliable in keeping the flaps open and staying open without them falling on their own. The next part obviously is Arduino Nano. There's probably other boards you could use for this, but I like the Nano because it's pretty versatile. I get the pre-soldered headers already on here. It's personal preference whether or not you feel comfortable soldering or not. I mean, I do have some that are not soldered, that you have to solder the header pins on. These are just a little bit easier to work with, and they only cost maybe a few bucks extra, so I highly recommend these. JST cables, connectors. I use these to connect like power supplies and wires going from the Arduino to different servos. You don't really necessarily need these, but they're nice to have in case you like want to disconnect things, like maybe a servo is going bad and you want to disconnect it real quick from a power supply. So it's personal preference whether you want to use these or not. About power on the servos, this is a 4 AA battery pack power supply. You'll need 2 of these. The reason I say that is I found that powering these off of a power brick, I could only get about 3 of these to work consistently, not all 4. They weren't all drawing 5 volts consistently. But I found that if I use 2 servos connected to one of these on each side, and you'll see that later when I show, that I was able to get 5 volts consistently powering the servos, and they weren't going wonky, basically. Glue gun. SureBonder makes an amazing wireless hot glue gun. I highly recommend it with their SureBonder cosplay glue. This stuff works amazing. I just found out about this at DragonCon when I needed hot glue. It sticks to PLA very well, like better than regular hot glue. So I definitely recommend this. You need wire strippers. I mean, you can use any kind. I have these nifty little ones. One is to add lights. These are just Neopixel LEDs. Have a 5 volt ground and power. So you would just solder the connectors here and then solder all of the wires together. Then is the data, so the ground and then power. And you can control whatever color you want. I have mine pulsing red when they open and turn them off when they close. That's optional. You don't have to add that. The next thing are these nifty little 3D printed hinges. So with the Mark 46 files, they didn't have hinges already built into the back flaps. So I wanted a way for them to hinge, but I didn't want the hinge visible from the outside. So I wanted to look more flush than having like a hinge stick up over where the flap would be. So these are on Thingiverse. I'll put the link below. You print them in place just like this, and you pop them off, and they're good to go. And then you can hot glue the flaps on both sides of this, and it works perfect. You'll need various bits of wire, screwdriver, and then I use M3 screws for the servos, for the housing, the mounting of the servo, and also some of the flaps screwed in. You can use whatever you like, but I found that these work pretty well, and I had some already, so that's what I used. Other things I recommend, if you're using a power brick to power the Arduino, or if you figure out a way to do the servos, you need a way for the power brick to stay alive. Basically, it needs to have a constant current going to it. I found these little keep alive, basically USB connectors. All they do is basically send a signal to the power brick to say don't turn off. And the power brick I use has like an on and off switch, but after a while if it's not receiving or something's not drawing power out of it, it'll cut off. But if you stick one of these in there, it never turns off, and you just plug your USB cable here to the Arduino, and it stays active the whole time. It'll never turn off. I got like a pack of these for like, there were 3 of them, and they're like 25 bucks. I know Crashworks also used to make I believe it's the Penelope board that's really amazing that I have in my suit also, but I haven't seen them sell that, so this is another cool alternative. I've also used, if you're in a bit of a bind and you can't get one of these or something else, wire a whole bunch of LEDs together until you get enough voltage and current drawing out of this to keep this thing alive. I used that in my Rocketeer pack when I needed something to keep the power bank active. Speaking of power bricks, this is the one I use. You don't have to use one this big, obviously, but I like it because it has 3 ports and 5 volts each, and they work pretty well. I have multiple parts that hook up to my suit. That's why I went with this. I need a soldering iron. Any kind of soldering iron works. Also, I recommend getting a hot knife. It's basically an X-Acto knife that's hot. It cuts through plastic pretty well. You can obviously use a Dremel or a soldering iron. It's kind of personal preference, but I found this was a little bit easier to use and a little bit more accurate when I needed to cut the holes for the servos on the back plate. So highly recommend getting one of these. They're pretty cheap on Amazon. So for the next part, I recommend printing a test piece. This is the right side of the back. It was a failed piece that I decided to keep and use as testing for the motorization, because I didn't know exactly where I wanted to put my cuts for the servos. So you can kind of see they're kind of bigger holes than you might necessarily need, but it worked pretty well. And you want to kind of do this because it'll help in terms of like where you need to know where you can see where I've outlined where I need to put the mounts for my servos on each side and which way I wanted the servos to go. So you would have a mount in here, and then the servo would have another arm going here into the flap and push it out and then pull it back in. It's up to you whether or not you want to do this. I definitely recommend it because you don't want to have a finished product and then ruin it by making a ton of huge holes and then being able to see it when the flap's open and it's just messy and gross looking. But entirely up to you. Alright guys, so here is the back, and it's beautiful, organized chaos. Yes, I know my wire management could be better, but I was in a con crunch and this is what we get. So we have 4 servos, 2 on each side. Each side is powered by one of these battery packs. So I have both of these servos powered by this battery pack, and then both these servos powered by this battery pack. And the reason I did that is what I mentioned earlier. It was when I tried to power all 4 off of a power brick. all three would work, and then like the third one would start acting up and then just start buzzing and then continually running. And it wouldn't always be this one, it might be this one. It was random. I couldn't figure out why. The only thing I could think is they were not all getting 5 volts consistently to each one. So that's why I decided to split them out. And I'm also powering the Arduino, which is kind of hard to see, but it's buried down in here. Also on a power brick, and I was powering all of that on the same power brick, and I believe there was some interference or something. Not really sure what was going on. So next, let's talk about servo placement. I went with this configuration. You can kind of depends on how you want to do it, but I found that this worked the best. And as you can see, it might be a little hard to tell, but there's the metal servo arm that comes with the servo, and then there's the plastic piece, and then another plastic piece that's connected to the back plate. Those two pieces come from the Plentiful Props aileron system that's on Thingiverse. I highly recommend you use these files. They're fantastic. He has a fantastic tutorial describing how he motorized his back flaps, which I used some of it like work to configure how I wanted to do this. So I highly recommend go view his stuff. His stuff is amazing and more well done than mine. But as you can see, this servo is sitting in a 3D printed mount. These mounts are also on Thingiverse, and I just have the servo screwed in. I had these mounts just hot glued into the back plate. The only other thing on this part is where I have this servo placed, there's a crease here. So the servo mount doesn't fit flat. So what I did was I took I had a bunch of 3D printed rafts that I cut up and I glued to the bottom of this mount, and then I slid them into this slot so that the mount would sit flush, so that this servo arm would sit flush with the mount and the servo. So it's up to you how you want to do it. I know it's a little bit wonky how I did it, but I found that worked, so that's the way I went with it. As for this side, this one I just glued all the way down. You have enough surface back here as long as you don't cut too big of a hole for your servo arm to move, for the mount to just sit flat. And again, I just have it glued. As for powering the Arduino, it's a little hard to see, but I have just a USB connector going to a normal USB cable, which wraps around to the front where I have my power brick that I mentioned earlier that has the 3 slots. It just sits on my chest, and then I plug it in and it powers this servo independently of, or powers this Arduino independently of the servos. Because remember, the servos were powering off the 4 AA's on each side. So if we look a little closer, I know it's hard to kind of judge, but I also have some extra wires in here, and these wires that are kind of the blue and yellow coming out of this hole, these are the ones that are going to the Neopixel lights that I mentioned earlier. I have some on both sides, and wire the power supply to the actual Arduino. So here I'm actually powering the lights, the Neopixels, off of the Arduino 5-volt pin to the LEDs, and then the data pin I've wired all 4 to the same data pin, because I want all 4 to come on at the same time. I don't need them to operate independently. If you wanted them to do a different pattern or operate different colors, then you would obviously put the data pin on 4 separate data pins on an Arduino. But if you want them all on the same light scheme and the same pattern, then you just need 1 data pin. So that's why I have all 4 of these tied together. So that's what this chunk of wires are going to. So those are the power, and then the ground on the Arduino, and then the data pin here. So let's talk about the switch. So this JSC cable is what I was talking about earlier, connects to the chest piece, which has an Arduino, another Arduino that is connected to a reed switch that's in my finger that triggers the servos to go up and down. So when I'm putting this on, I can connect this to the chest piece real quick, and disconnect it when I'm taking it off, so I don't have to have another Arduino sitting back here. I have everything in the front powered. I also have another JSC cable connector here. This one is solely for the power supplies. You don't necessarily need to have that. I did it just in case I needed to disconnect the power quickly because maybe one of the servos is going nuts, which happens sometimes. You don't necessarily need this, but it's sort of a nice to have just to quickly disconnect your power supply if you need to. Let's talk about servo arm placement. So this servo is powering or pushing up this smaller flap. And if you notice, I have this servo kind of upside down if my camera will focus. So starting at the position, I don't start at position 0. I'm actually starting at a higher position because what I recommend when you first put these on is don't have these servo arms attached, or if you do, don't have them attached to this flap yet, because you need to see which way the servo is going to turn. Since this one's upside down, it's going to turn this way counterclockwise and then clockwise. So when you want it to push out, you want it to go clockwise. And so you want it to start at a specific position because they don't have negative degree values. And we'll kind of get into that in the coding. But anyways, so I took this off just to kind of demonstrate how you want these servo arms positioned in here. So what you want to happen is this servo pushes out and you've got your servo helper arm sort of in this kind of position. Your servo arm won't be out that far. All right, so let's go over the placements of where your arms need to be. As you can see from the inside, the servo arm has pushed the 3D printed helper arm onto the pivot point out. And you can see kind of underneath that it's just hot glued in to the spot. I recommend doing this when the arm is at rest and the flap is down. That way you can press the helper arm into the back flap and it'll stay in the position you need it to when it opens. So if we see when the servo is engaged, you can see it's like pushing out. And then when we close it, the servo is back into like the actual metal arm, which is not red, it's usually silver, it just got spray painted, is in like almost a vertical position with the helper arm at a slight 45-degree angle. And so that's kind of the ideal position I found for this middle flap. So if you see here, I've got this helper pivot point here, but there's a lot of space in here, and I probably could have modeled something to fill that space, but I was on a con crunch. So what I did was I took several cut up pieces of raft material from a previous print and just hot glued it together until it met the depth that I needed for it to hit the back flap and the pivot point. Again, you could probably go into a 3D editor and make this pivot point a little bit bigger, wider. I tried it a couple times, couldn't get the exact height I needed, so I kind of just rushed it and used cut up raft material. So it's really up to you what you want to do. As for hinge placements, these two have 2 hinges on both sides, and then these bigger ones, I have 1 hinge on each corner, and you see I screwed in the hinge on that side as well as on this side. For these hinges, they are glued in with wrap material on the bottom, but no wrap material on the top, and they're just glued straight onto the flap. Now, the great thing about these 3D printed hinges is you can pop them off and pop them back on once you have the bottom one glued on. So what I did was I glued those on where I knew I wanted it to be, and I tested to make sure it's still hinged, and I popped this off, and then I put glue onto the hinge part here, and then I just pushed it down onto the glued hinge, and then that secured the flap onto the other side of the hinge that's already on there. And then if you ever need to do any kind of like maintenance, or say this becomes unglued or whatever, these can just be popped right off of the hinge. These hinge points just come apart. They just snap together. So you can just, I can get it. So like that. And then you just snap them back on. Talking about the LED strip lights, these are just hot glued in. So I've got a strip of 9 LEDs that are all wired back to the same data port and powered off the Arduino on the inside that I talked about earlier. This is totally optional. I think it adds like a cool glow effect to the suit, but totally not necessary. So I hope you liked the video. I know I went over the hardware side of it. I have a part 2 that's going to go over the software and coding with the Arduino and the wiring. If you want to go take a look at that. If not, if you liked it, appreciate the like button. Maybe I'll do something else in the future. We'll see. But until then, see you.